Hello. In my last series, I'm doing these classes basically to sort of as a review, mainly for my wife and I, of concepts that have to do with electricity, as we're both ham operators. But I thought that might also share some of the information and post some of these videos on Facebook for those that may be interested. Now, in some earlier videos, we began to talk about the basic concepts and theories involved in electricity and in the field of electronics. And we started out relatively basically. We talked about three quantities or three measurements, basic measurements that come into play pretty much any time that you're working with electricity. Voltage, which represents a difference of potential between a positive side of a positive pole and a negative pole, where the negative side represents an excess of electrons, and the positive side represents an absence of electrons. And we talked about how that the voltage is the electromotive force it's not the movement of the electrons itself, but it's that difference of potential, that potential energy or electromotive force that causes electricity to flow once there is a path. And that's the second big concept that we talked about, is that for electricity to flow, there must be a path, and by a path, what we mean is a complete circuit from a starting point back to the same point. Could be through several different paths, but the key is that essentially forms a closed loop. That is that there is a path from the starting point back to the starting point for the electricity to flow. The second quantity that we talked about was current, and current is measured in amps or amperes. That actually represents the flow of electricity, and essentially the amp, the basic unit of measure of current flow, is it's a measurement of 1 coulomb of electricity flowing past a given point in 1 second of time. That is usually pushed through there by 1 volt. Okay, and then the final quantity that we talked about was what we call resistance to current flow, and resistance is measured in a quantity referred to as ohms. So if you think of a runner running along a path, let's say an asphalt path, there's not really much resistance to his or her being able to run, and so the runner's able to go at a fairly fast clip without much in the way of impediments to getting from point A to point B. Well, for various reasons in the field of electronics, it's necessary and even advantageous to introduce a little bit of resistance into the circuit. So this would be a situation where the runner is now, instead of running along the asphalt, is running along a beach with really loose sand, or maybe running through a marsh or something like that, where each time that the runner tries to pick up his or her foot, there's resistance. There's something pulling the runner's foot back down, and that's similar to the concept of resistance in an electronic circuit. The resistance is what opposes the current flow in the circuit, and then, as I said, there's various reasons why you may want to introduce resistance, a certain amount of resistance, into the circuit. Now, in my previous videos, we were just dealing with direct current or DC electricity, and we talked about the example of the Christmas lights, and we talked about that if you have what is called a series circuit. So this is just a quick review, and then we're going to get into magnetism and alternating a current, or alternating current, and we'll talk about how that relates to the field of electronics, and in particular to communications. So, but just a real quick reminder, refresher. We talked about a couple of different types of circuits that you can have. You can have a circuit that's called a series circuit, where all of the current flows, only has one path to flow. So for example, I don't know how well this shows up. Let's see. There we go. Okay, so I've sort of drawn here an example of autofocus always gets me. Okay, I've drawn an example of a series circuit. Here would be the voltage source, the negative side, here's the positive side, and notice that the wire forms a loop, and there's only one pathway for current to flow. And we'll say that these two little squiggly lines are this set of squiggly lines represent resistors, or in this case, light bulbs. And we talked about that since you have to have a complete loop for the negative electrons to flow from the negative side of the battery or the voltage source back to the positive side. If anything happens to this loop, in other words, if we put a switch in there, or if there's a short circuit and a light bulb or something like that, where the circuit opens up, then no electricity will flow. It will immediately stop because now you don't have a complete path. So that's called a series circuit. And we talked about that in the context of light bulbs. Okay, and we talked about how if you were putting up Christmas lights and you had them wired in series, if one of the bulbs burns out, then it's going to cause the whole string of lights to go out. And so you have to go through and check each light bulb in order to figure out which one is the one that's burned out. Okay, we also talked about a different kind of a circuit, which is referred to as a parallel circuit. And we talked about the advantages of hooking your Christmas lights up in parallel so that if one of the bulbs burned out, there would still be an alternate path for current flow to the other bulbs, and they would continue to stay lit even if one of the bulbs burns out. Okay, so an example of that circuit might look something like this. Okay, notice that in this circuit, my dog's excited today. Notice that in this circuit, we now have our light bulbs wired in parallel. Okay, so let's say that this bulb number 2 burns out. Well, if this bulb were to burn out, there still are other paths available for the electrons to flow from the negative side to the positive side, and so these other bulbs would actually stay lit. And that's called a parallel circuit. Here again, we're still talking about direct current. We're not getting into the issue of alternating current. And the resistors or resistances that we have in our circuit are essentially just resistors. In other words, there's nothing that's in this circuit that's reacting with it. It's just a straightforward resistance. Okay. Now, in the next set of videos that I'm going to be making, we're going to move away from direct current and we're going to start talking about some concepts that actually are very important in the field of communications. In fact, if there were if we didn't have alternating current, there would essentially be no radio communications, no cell phones, none of that stuff. So alternating current is a very important aspect of electronics and is used in many different ways. Now, because we are going to be talking about alternating current, we're also going to be talking about some related concepts. And so in my next video, I would like to talk about magnetism, and we're also going to talk about a type of device that's referred to as a capacitor, and which involves electrostatic fields. So we're going to be getting into two different concepts, and this will lead into our discussion of AC circuitry. Magnetism, and then also capacitance or capacitors, and we'll talk about the differences that the introduction of a coil or a capacitor, what difference there is in a circuit once you put these elements into the circuit versus a traditional resistor. Up to now, we've just been talking about basic resistors. Most resistors are, or at least the cheaper ones, are made of carbon. And essentially what happens is, like I said, going back to my runner's analogy, they're not reacting to the circuit. They just... oh,